How does a machine decide in an instant? Imagine a self driving car that suddenly detects something unexpected on its path. Is it just debris or a human being? In that single moment, with one choice to make, it must determine the safest course of action. Every decision counts. We live in a world filled with uncertainty, from weather forecasts to medical diagnosis. Machines face the same challenges: incomplete data, unpredictable conditions, and split second risks. So, how do they navigate this chaos? It's not about having all the answers, it's about quantifying the uncertainty. By teaching machines to weigh risks, adapt to surprises, and make the best possible guess when perfection is impossible. This is what we call the probabilistic machine learning. Here, AI doesn't just predict, it thinks in shades of uncertainty. It's how computers make good choices even when they are not completely sure what's going on. Just like how you might grab an umbrella when the sky looks dark. These machines look at what they know and make their best guess about what to do next. Today, we are going to look at how this all works. We will explain simple ideas behind how machines handle uncertainty. Because understanding this is not just about technology, it's about making better decisions in an uncertain world. So let's get started. Traditional machine learning focuses on prediction. For example, asking, is this email spam or not? Probabilistic machine learning goes deeper. There is an 87% chance this is spam, but we are 10% uncertain due to new keywords. Instead of black and white answers, it quantifies uncertainty. Why does this matter? Because the real world is messy, sensors make errors, data is incomplete, and models need to know what they don't know. Three ideas power probabilistic machine learning. Number one, uncertainty. Models don't just predict, they measure confidence. For example, it's 90% sure it's a cat. Second, probability distribution. Instead of fixed outputs, models return probability distribution, for example, a Gaussian distribution, to show possible outcomes. Number three, Bayesian thinking. Update beliefs as new data arrives. Think of it like learning loop for AI. Imagine predicting tomorrow's weather. A deterministic model says it will rain. A probabilistic model says 60% chance of rain with a 20% margin of error. That extra layer helps you decide whether to carry an umbrella or risk it. Behind every smart AI decision lies a beautiful piece of mathematics called Bayes' theorem. Don't worry, while the equation might look intimidating, the idea is simple. We update what we believe as we get new evidence. Let me show you with an example. Imagine you take a medical test that's 99% accurate. Sounds incredibly reliable, right? But here's where Bayes' theorem reveals something fascinating. The equation tells us to consider three things. First, how common is the condition to begin with? This is our prior belief. In this case, only 1% of people have the condition. In the equation, this is probability of A is 0.01. Second, how likely are we to see this test result if someone is actually sick? This is our likelihood. The test correctly identifies 99% of sick people and 95% of healthy people. In the equation, this is probability of B given A, or 0.99. Finally, what's the overall chance of getting a positive test? This comes from combining both possibilities. Either you are sick and test positive, or you are healthy but get a false positive. This is probability of B in our equation. When we put these numbers into Bayes' theorem, something remarkable happens. Despite the test being 99% accurate, if you test positive, your chance of actually being sick is only about 17%. This is exactly how modern AI thinks. It doesn't jump to conclusion from a single piece of evidence. Instead, it carefully weighs initial probabilities against new evidence. Whether it's a self driving car deciding if an object is a pedestrian or a weather system predicting tomorrow's forecast. AI uses this same principle of updating beliefs based on evidence. So, next time you hear about AI making smart decisions under uncertainty, remember it's not magic. It's this elegant mathematical principle at work helping machines think probabilistically just like good human reasoning does. Probabilistic machine learning is not just academic, it's critical for responsible AI. Models that know their limits can ask for human help, avoid overconfidence, and handle edge cases. Whether you're a data scientist or a curious learner, understanding probability turns you into a better decision maker. So, to recap, probabilistic machine learning quantifies uncertainty using distributions. It uses Bayesian thinking to update beliefs with data. The math is powerful but intuitive once you grasp the basics. If you have enjoyed this, smash the like button, subscribe, and hit the bell for more deep dives. Let me know in the comments what should I cover next. Thanks for watching and stay curious.